Okay, so when we are changing the dimensions of a figure, it can be referred to as a scale factor. So if I asked you what was the scale factor, I'm asking you what was it multiplied by? What were the dimensions multiplied by that helped you get the new dimensions, that helps you change it? So when you think about changing dimensions, you can put that together with the words scale factor also. Or here's another way the book talks about it. They also call that a ratio of corresponding sides. So would you fill in those blanks, please? Because when they use those words in your book, in your problems, you want to know what they're talking about. Ratio of corresponding sides. Know what I say? They mean the same thing. Scale factor means the same thing as ratio of the corresponding sides. Let me give you just a really quick example of what I mean here. Not saying that you have to draw this on your notes, but I just want to show you what we could, when we're talking about corresponding sides and ratios. If I have that first rectangle that's a 3 by 4, and I want to double its dimensions, what would the dimensions of the new figure be? 6 and 8. What would the scale factor be? What's the scale factor? If we double the dimensions, what's the scale factor? 2. 2 would be considered the scale factor. Well, if we double the dimensions, the scale factor is considered to be 2. The ratio of corresponding sides means the same thing, so it should come out to be the same thing. So the length of the original one corresponds with the length of the old one. What is 6 over 3? What's that ratio simplified to? 2. And corresponding sides, 8 over 4. What's that simplified to? 2. So in other words, when you have those corresponding sides, you set up a ratio of them, you compare the new to the old, it should always come out to be the scale factor. So the ratio of corresponding sides really means what's the scale factor you use? What's the thing you multiplied by to change the dimensions? Okay, well if the figure gets larger, then the scale factor or the ratio of corresponding sides better be what compared to 1? What'd you say, Brighton?
Big.
It better be larger than, yeah, it better be bigger than 1. For the figure to get larger, you better be multiplying by something bigger than 1, larger than 1. So if the scale factor is 2, you expect the new figure to be bigger, don't you? If the scale factor is 1/2, what happens? It should get smaller, shouldn't it? It should get smaller. So if the figure gets smaller, the scale factor or ratio of corresponding sides must be smaller than 1. And you're gonna need to do a lot of critical thinking with this stuff that we're working with right now. You're gonna have to say to yourself, if you were told to find the scale factor, and you started with a figure, and the new figure was bigger, and your scale factor is less than 1, you should be saying to yourself, how can the scale factor be less than 1, but yet the new figure is bigger than the other one? It should have been more than 1, so I must have done something wrong. So this is really important that we take the time to realize that what should the scale factor be? Should it be bigger than 1 or should it be less than 1? Should it be smaller than 1? And then here's just a little note I want you to read with me. When asked for the ratio of perimeters or the ratio of the areas, they're going to ask you that a lot. They're really asking you how many times longer, that's perimeter, how many times longer or bigger, that's area, does the figure get? We could also say it this way, how many times shorter or how many times smaller did the figure get? So when they're asking you for those ratio of perimeters, they're really just asking you what happened to the perimeter. How much did it change by? How would it compare to the other one? Asking for ratio of areas, same thing. They're asking you how does it compare to the other one in size. Okay, so let's do some practice here. We have a 4 by 5 inch photo that's going to be enlarged by multiplying each dimension by 2 to form a similar photo. Okay? There's three things we have to answer here. What is the ratio of corresponding sides? What is the ratio of perimeters? What is the ratio of areas? Dakota, could you sit up for me, please? So, the first thing I want us to do is I want us to make a little note here. When you set up your ratios, no matter what you're setting up the ratio of, you can put this in your notes here. We need lots of white space here, so don't write too big, okay? The ratio, you're going to compare the new figure to the old. Compare them in that order. What's the new figure compared to the old figure? That will give you a correct ratio. Okay, well, let's just draw some little pictures here. Let's have our 4 by 5 inch photo. Well, that's not a very good rectangle. Let's have a 4 by 5 inch photo. And then it says we're going to multiply each dimension by 2 to form a similar photo. So we're going to double the side length, right? So we're going to make this width double, and we're going to make the length double. So what would the new length be? Instead of 5, it would be 10. And the new width, instead of being 4, it will be 8. Okay. So there's our picture, our photo that we enlarged. And we have to, first of all, find the ratio of corresponding sides. So for a ratio of corresponding sides, can anybody give me one of the ratios that we could possibly set up for that one?
8 over 4.
8 over 4. Or, what's another one?
5.
Or 10 over 5. 8 compared to 4, new to old. 10 compared to 5, new to old. Either way, what is it?
2.
2. And what did we say above? The ratio of corresponding sides is the same as the what? Scale factor. And how do we know that 2 is the scale factor? We multiplied by 2, didn't we? Multiplying by 2 tells us the scale factor is 2. The ratio of corresponding sides, we said, really is the same thing as the scale factor, so we should have ended up with 2, or we did something wrong. Okay, next we'll do the ratio of perimeters. Anybody right now think they know what the ratio of perimeters might be? From what we learned yesterday, Brighton?
Taking all the sides, adding together, and doing that with the new and old, and put the new over the old one.
Okay, so that's how we would get the perimeters, and then we would set up the ratio. Anybody think they know what the final answer will be? What will that ratio be? You know, the ratio of corresponding sides is 2. Anybody have a prediction for what they think the ratio of the perimeters will be? Isaac?
36 over 18.
Okay. So again, what does that simplify to? Okay, let's just do it, because you guys don't want to make predictions for me on what we learned yesterday. You seem to want to find the perimeters. Let's do it. Let's find the perimeter of this first one. Perimeter equals. How do we find perimeter? Add up all the sides. Well, that means that we have 2 4s, because there's a side opposite it that's a 4, plus 5, plus 5. There are 2 sides that are 5 and 2 sides that are 4. So that equals what?
18.
18. Okay.
That's 26.
Now let's find the perimeter of the other one. Perimeter equals 8 plus 8. There's 2 sides that are 8. And 10 plus 10. And that equals 36. Okay. So then we'll go over here and say, okay, the ratio of perimeters, new perimeter is 36 over old perimeter is 18. What's 36 divided by 18? 2. Okay, let's just stop right now, right here, and let's process what just happened. Same thing that happened to us yesterday. When we doubled the side lengths, when we doubled the dimensions, what happened to the perimeter? It doubled also. It got twice as long also. So the ratio of the perimeters, that's what they're asking for. What happened to the perimeter? It got twice as long. By by doubling the dimensions, the perimeter also got twice as long. Any questions so far here, before we move on and leave you behind on something that you don't understand? Okay, our next question is, what is the ratio of the areas? So how do we find the area of a rectangle? Length times width, so 5 times 4. What's the area of the original photo? 20. Let's find the area of the new one. 10 times 8, and that equals 80. Okay. Ratio of the areas. Which one goes on top? The new one, so the 80 over 20, and what does that divide up to be? 4. So the ratio of the areas is 4. Does this sound familiar? When we doubled the dimensions yesterday of our rectangles and our rectangle and our square, what happened to the area? Did we talk about that? What, that bedroom? You're adding on to your parents' house. You want to double the dimensions of your bedroom. Is your bedroom going to get twice as big? No, it's going to get how many times as big? 4 times as big. 2 times 2. The scale factor times itself. Okay, now what we want to be able to do, though, is we want to be able to answer these questions without always having to draw a picture and find all of this stuff, because we came to a conclusion yesterday that we should be able to use that conclusion all the time. So let's try this one without drawing a picture and without finding the perimeter and without finding the area. I'm not saying you can't. If that's what it takes for you to be able to answer the problems, do them, draw the pictures, do what you need to do to get the answers. But I want us to try and critically reason out, how can we do it without the picture? Okay, so we have a rectangle that has a width of 3 inches and a length of 12 inches. Each dimension of the rectangle is multiplied by 1/3 to form a new rectangle. You know what? Let's write what the scale factor is. What is the scale factor? 1/3. It's what we multiply by. Okay, now let's stop and process. What should happen then? Should the new rectangle be bigger or smaller? It should be smaller, shouldn't it? Yeah. Okay, now the question they're asking is how would the ratio of the perimeters compare to the ratio of the corresponding sides? How would the perimeter change compared to how the sides change? That's really what it's asking. How would the perimeter change according to how the sides change? So what do you think the ratio of corresponding sides is? Let's answer this one first. What do you think that is? Look at to the very first thing we talked about in our notes. What's at the very top? What does it say? Ratio of corresponding sides is the same as what? The scale factor. What's our scale factor? 1/3. So the ratio of corresponding sides should be 1/3, shouldn't it? Well, what would the ratio of the perimeters be? Well, we didn't find the perimeter. Do we have to? What do you think? Do you think we really have to go through all the work of finding the perimeter? And then how are we going to do it then? What do you think the ratio of perimeters is then? 12/3? Well, we got to be careful. 12/3 is really the 2 dimensions of our original rectangle. We can't really just set up a ratio of the sides of one rectangle. 24/6. And where did 24/6 come from? Okay, but 12 plus 12 would just be adding 2 lengths together, and then 3 plus 3, that'd be 6. So right now you're finding for me the perimeter of the original rectangle. It's 30, isn't it? 12, 12, okay. picture. We have 12, 3. What would this side be? 3, and this is?
12.
Okay, so what's the perimeter of this one? 12 plus 12? 24. 3 plus 3? 6. 24 plus 6? 30. Okay. Remember now, our new rectangle, we said we get smaller because the scale factor is 1/3. So we have a smaller rectangle now. What would its length be? What's a third of 12?
4.
4. What's a third of 3? 1. What's the perimeter of our new one?
10.
10. Okay, ratio of perimeters, what do we have to do? Which one goes on top?
New.
New, what's the new?
10.
10
over 30.
over the old.
3.
What does 10 over 30 simplify to?
1/3.
1/3. So what's the ratio of our perimeters?
1/3.
1/3. Okay, remember what happens? The perimeter changes by the same amount as the scale factor.
Therefore, 1/3 is a scale
So no, now we're gonna talk about then what happens too. So therefore, the new rectangle rectangle's perimeter. Let's get that down. Therefore, the new rectangle's perimeter is how much of the old one? 1/3. Is 1/3 the perimeter of the original? The perimeter changes by the same amount as the dimensions do. If the dimensions become 1/3 as long, so does the perimeter. That's what we just found out. We should have been able, from our conclusion, we should have been able to do that without the picture, but that doesn't mean we can't draw it. We confirmed it with our picture. Okay? Anybody have questions? Because the next thing they're going to ask is how would the ratio of the areas compare to the ratio of the corresponding sides? Remember, what words can we put in place of ratio of corresponding sides? Scale factor. They're really asking us, how would the area change according to the scale factor? Well, since our scale factor is what? What's our scale factor again? What's our scale factor? 1/3. What did we learn in our exploration? What did we conclude is going to happen to the area?
It's going to get smaller.
It's going to get, well, the scale factor tells us it's going to get smaller. How many times smaller?
2 times.
Is it going to be 1/3 the size?
Yes.
Again, let's go back to the bedroom. You double the dimensions. Did your bedroom get twice as big?
No.
It got 4 times as big. It got 2 times 2. So is this rectangle really going to only be 1/3 the size of the original one? What's it going to be? 1/9. The scale factor times itself. So the area, ratio of areas is 1/3 times 1/3. The scale factor is 1/3. We have to multiply it by itself. When you multiply fractions, you multiply across the top, you multiply across the bottom. What's 1 times 1? 1. 3 times 3? 9. Not adding, multiplying. 1, 9.
Sorry.
So therefore, what are we going to say about our new rectangle? Therefore, the new rectangle is what?
1/9.
1/9 the area of the.
Is 1/9 the size? Yeah, is 1/9 the size of the original one? Now, we'll very quickly verify it up here with our, these are still the same, we're still talking about the same rectangles. What's the area of this one? How do we find the area of a rectangle?
Oh, 36.
Length times width, so it's 36. What's the area of
4.
this one? 4 times 1, 4. New over old, 4 over 36.
Divided, that'd be 1/9.
4 goes into both of them. 1 time it goes into 4. 4 goes into 36 9 times. Look at there, the ratio of the areas is 1/9. So the new rectangle is 1/9 the size of the original one. 9 of those should fit on top of the starting one. Questions? You have to do some critical thinking. If you can't process it without making yourself a visual, then do that. Do what you have to do. Help yourself out. Okay, let's go to the back side. We're going to practice a couple more things that'll show up in your homework. So we have a square. Has a perimeter of 48 centimeters. Each dimension of the square, let's see, what does it say here? Is multiplied by a scale factor. Didn't tell us what it was. And the new square has a perimeter of 16 centimeters. What was the scale factor used? Always just find that. What do you think, Trey?
Solve for X.
Solve for x. Okay, well, do we have an x in there?
Scale factor.
Scale factor you want to call x? Okay. So x would be the scale factor is what we need. Okay, well, how about we just leave, like x out of the picture and make it a lot easier than that? Can we try that? Can we try something that says, remember, what did we learn? The scale factor is the same as, it's on the front side, the scale factor is the same as the what?
Ratio of corresponding sides.
Ratio of corresponding sides. And the ratio of corresponding sides is also the same as the
Scale factor.
ratio of the perimeters. Remember, don't the ratio of perimeters turn out to be the scale factor? Okay, well, trust me, it does. Okay, let's put this down. Let's write down ratio of perimeters equals the scale factor. And we can call that x if we want. The scale factor and the ratio of the perimeter should always turn out to be the same. Always. The perimeter changes by the same amount as the dimensions do. That's what this is saying. So the ratio of the perimeters. Do we know the perimeters? Did they give them to us?
No.
They sure did.
Oh, yeah.
A square has a perimeter of 48 centimeters. That's our original right here. And the new square has a perimeter of 16 centimeters. There's our new. Remember, we do new over old, right? So what are we going to put, Trey?
16 over 48.
16 over 48. And then we'll call that, remember, we're solving for x, aren't we? We'll call the scale factor x. I wonder what 16 over 48, does that divide out nicely? What happens?
It's 0.3 repeating.
It's 0.3 repeating. Anybody just happen to know what 0.3 repeating is as a fraction? 1/3. Or in other words, 16 can go into both of those. So 1/3 is our scale factor. So we're going to write in a sentence here, the scale factor used is 1/3. Oh, just like the one we just did on the front side, sounds like. Okay, so the scale factor used is 1/3. The ratio of the perimeters is the same as the scale factor, is the same as the ratio of corresponding sides. It all works out. So here's our final answer. Did our new square get larger or smaller? It got smaller. It has a smaller perimeter, so it had to have gotten smaller. What do we expect when something gets smaller? What do we expect the scale factor to be? Less than 1. Is 1/3 less than 1?
Yes.
Yeah, so I think we did all right. Questions? Okay, now let's try the next one. We have a triangle that has an area of 20 inches squared. Each dimension of the triangle is multiplied by a scale factor. They don't tell us again what it is. But the new triangle formed has an area of 180 inches squared. What was the scale factor used? Oh, we gotta stop and think. What happens to the area again? Does it change by the scale factor? If you double the dimensions, does the area double? If you triple the dimensions, does the area triple? What happens? If you double the dimensions, it gets how many times bigger? 4. 2 times 2. If you triple the dimensions, how much bigger does it get? 9 times bigger. 3 times 3. So we're going to have to, if we have to find the scale factor, we're going to say that the ratio of the areas is equal to the scale factor times the scale factor. We have to take the scale factor times itself. So the ratio of the areas, we can say, is the same as the scale factor times itself. The scale factor times the scale factor. Okay, well, the ratio of the areas. Do we happen to know the areas?
Yes.
What are they?
20 and
180 and 20. So which is this one? This is the original or the new? What's this one?
Oh, that's so old.
That's the old, the original. Yep. Okay, so there's our original or old one. And our new one is 180. So how are we going to set up our ratio?
180.
180 over 20. Let's figure out what that equals first of all. What does that become? Let's use an arrow here. What's 180 over 20 become?
90.
90?
9.
9. There are 9 20s and 180. So now we have to say, okay, 9, our ratio of areas, has to equal the scale factor times itself. So the ratio of areas, which we found to be 9, has to equal the scale factor times itself. What times itself is 9? 3. And what was the question we were asked? What was the scale factor used? So what was the scale factor used? 3. The scale factor used is 3. That's our final answer. We had to do some stuff to get it, but we did. It got 9 times bigger, but that doesn't mean the scale factor was 9. It means that it was whatever times itself is 9. So the scale factor turns out to be 3, not 9, even though it got 9 times bigger. Do we feel good about our scale factor? Should it be greater than 1?
Yes.
Why?
Because
Because it got bigger. So the scale factor better turn out to be greater than 1. Okay. Questions left that we need to answer? Cameron?
What if the scale factor was 1, but they didn't get any bigger?
No. If the scale factor was 1, we wouldn't really change the dimensions, because multiplying by 1 does what?
It's the same.
Keeps it the same, doesn't it? So if we're going to use a scale factor of 1, we're really just replicating what we already had. We're going to get the same thing, aren't we? Yeah. Rose?
And how do you see if if the scale factor is going to be less than 1? Do you just divide the original by the new and that's what you do?
You always, whenever you set up your ratios, you always put the new over the old or the original. You always set it up that way. But then you go back to the problem and you just read and say, okay, if you ended up with a number greater than 1 by setting it up that way, so you put the new over the old, you end up with a number greater than 1. If you look back at the problem and you say, did what we were working with get bigger? Because it should have. So in this case, we started with one that was 20 inches squared, and it got up to 180 inches squared. So it got bigger. So we better get a scale factor larger than 1 then. But if what you started with got smaller, when you're done doing your new over old, it better turn out to be a number less than 1. Okay? Does that answer it? Anybody else?